Hi, everybody. This is Eric, and welcome back to Reading the Effin' Docs, where we learn Solidity together. And today we are still in the basic section. We have another example smart contract for you. This one called Safe Remote Purchase. Okay, so now let's imagine a scenario that we want to buy an item from somebody who we don't know, and we don't feel like dealing with Amazon or eBay or any other online Web 2 marketplace, and we want to buy directly from them. But how do we know that they're going to send us the item and not just run with our money? So the authors of the Solidity documentation came up with a plan, and that is our safe remote purchase contract. So I already went ahead and opened this up in Remix. And what do we have here? So we have 5 functions, including the constructor. Let's look at our state variables. We have a value, which is the price of the item, seller, a buyer, and enum called state, which we will get into in a second. And that's pretty much it. We have some custom modifiers, errors, events, and etc. So this state here, an enum is basically, you know, each one. No, so it's a user-defined data type, not quite the same thing as a struct. Each one of these items created, locked, released, inactive. These are actually just UINTs, but we use them to help us, kind of manage the state of our smart contract, and we'll go a little bit deeper in a second. So if you remember, the one way we can think about a smart contract is as a state machine, and I went ahead and made a little diagram here. So this is going to be the state of our contract. And when this contract is created, it's created by the seller. And suppose we want to and he wants to sell a teddy bear, and the price is $50. So the seller deposits $100, and he is going to get that back if everything goes smoothly. And if it doesn't, and if he decides to maybe not ship the item, then this money gets locked in escrow, and he can't get it back. And likewise for the buyer is going to send in more money than the item costs. And if for whatever reason things don't go properly, then he doesn't get his money back either. So both parties are incented to make sure the transaction handles smoothly. And so that's the catch. That's the gist of how we're making this transaction in a trustless manner. So these states correspond to a state of the smart contract, and we're adding names to them. So when the contract is deployed, we are by default in the created state. Seller deploys the contract, sends in $100, which 50 is going to be an escrow. 50 is going to be the price of the bear. Now from here, 2 things can happen. The seller can decide, I changed my mind, I don't want to sell this item anymore, maybe it has too much sentimental value, and he can call the abort function, and that will refund his money. And we go over here to the inactive state, and you can see how the seller gets his refund. Or the buyer can decide, okay, that price works for me, I want to buy this item. He sends in $100, or she, and 50 of that will go to the cost of the bear, and 50 of that will go into escrow, which will be locked in forever if things don't happen smoothly. So he calls the confirm purchase function to do that. And now once that transaction completes, we're now in the locked state. So there is now $200 in the contract, and the buyer variable is set. And now from here, there's only one way to get out of this state, and that's to call confirm received, which the buyer does. So at this point, we're in the lock state, and the seller says, okay, I'll go ahead and ship that bear over to the buyer. Now the buyer can say, all right, I got the bear, and I want my other $50 back. So I'm going to call confirm received. And that once that completes, our contract will now be in the release state. The buyer will get his $50 back, and the other $50 will go to the seller. And now we're not quite done yet. The seller can decide, okay, great, everything went smoothly, now I want my money. So then he gets to call refund seller, and then he will get $150. He will get the initial $100 that he put up and the $50 for the cost of the, cost of the bear. So once we're in the inactive state, we know that the seller got his refund. And that's basically just a way to visualize how the states of this contract, how the different phases of the transaction of the sale works. And this is a great way to to think about your smart contract. So now let's go ahead and I'm going to compile it again. Let's go ahead and deploy it and play around with it. So let me get rid of this. So now imagine we're the seller and we want to sell a bear for, all right, we already have 101 ETH. We want to sell a bear for, say, 2 ETH. I'm sorry, 1 ETH. So we send 2 Ether. Now we click deploy. Now by default, you can see, let's go to our state. This returns 0. Notice it's a uint. So this is really a uint, but for, ease of reading your contract and thinking about your contract, we get to name these, a word that's helpful for us. So this will by default be in the created state. So we can see that's at state 0. And well, now who's the buyer? Well, we don't have one yet. This is going to return a 0 address. This variable here has not been set yet, but we do have a seller now because the seller by default, deployed the contract. So we do have a seller address, which is our address here, OX5B3. And the value of the teddy bear should be 1 ETH. There you go. 1 with 16 zeros. That's 1 ETH and measured in way. And now, where are we? So we're here in this initial state. We sent in 1 ETH. We defined who the seller is and the value of the item. Now it's up to the buyer to this. Now he can call abort. Let's go ahead and call abort, see what happens. So let's look at our balance here, 99.9 ETH. When I call abort, just go back to 101.999 ETH because we get our money back. We call abort that transaction. Let's see, that transaction succeeded. We can see here our balance is back to where it was. We got our money back. So we're going to deploy. So that's inactive. So we have to deploy this again. So let's call, okay, let's sell the bear for 3 ETH. So we send 6 and now we deploy. Now we can see still don't have a buyer. We do have a seller. Our state, we're still in 0. But this time, let's pick a seller. Let's grab this guy, account number 3. So he is 100 ETH. Now the cost of the bear is 3 ETH, but he needs to send double that amount. So let's put in 6 here. So if we put in 5 and we call, what's the name of that function? Confirm. I think it's confirm purchase. Confirm purchase. This should fail. But if we send 6 ETH and call confirm purchase, okay, that transaction succeeds because we had to send in double the amount of the item. So now we should be in the lock state. The buyer variable should be set. And our buyer, you can see we now have, we started at 100 ETH. We now have, 94 or a little less, if we factor in gas fees. So now we should have a buyer. There you go. Our state should now be 1. And the value of the item is 3 ETH. So where are we now? We're in the lock state. So now, imagine the seller gets to ship the item over to us. And we, as the buyer, we can confirm that, yes, we did, in fact, get the item. So we can go ahead and release the seller or get our money back and give the seller the option to get his money back. So let's confirm received item. That should succeed. The state should now be 2, which is 0, 1, 2. We're in the release state. We are now here. We have our refund as the buyer, or a partial refund. So now, yep, we're back at 97 ETH because the bear costs 3 ETH. It's a very expensive teddy bear. So now we have our money back as the buyer, but the seller needs to call another function to get his money back. So he needs to call refund seller. So now let's go back to, so as the buyer, if we call this, that'll fail. So we need to go back to the seller's account and call refund seller. That transaction succeeded. We can see the seller, we got our money back now. And if we call state, this should be in state 3, which means 0, 1, 2, 3. We're now in the inactive state. The seller has his refund, and everything's complete. And that's how it works. So now let's go ahead and dive into the code. Okay, here we are back in the contract. And first thing I like to do is look at what are our state variables. Okay, so we have a public uint called value. This is going to be the price of the object that we buy. So in our case, a teddy bear. We have an public payable address, 2 of those, one for seller, one for buyer. So, one is the seller, person selling the item. The other is the buyer, the one who will buy the item. And these are actually, once these get initialized, they're going to stay like that for the lifespan of the contract. And lastly, we have this public state variable. It's called state of type state, which is a custom enum that we defined right here. And it has 4 states: created, locked, release, inactive. This will default to created because that's the first state, and that will have that's actually going to be uint of 0. So that's going to have default. And as we interact with the contract, the state will change from locked to release and eventually inactive. So this is the only variable that will actually change. Now what else we have here? We have some custom modifiers and errors and events. So we have one called condition. So this is actually a pretty generic modifier you can add to any function. And all you do is you pass in a condition, some kind of expression. If it resolves to true, then your function can continue. If not, it will revert. We'll have a few more modifiers: only buyer, only seller. So only buyer if message.sender. If the person calling this function is not the buyer, it will revert, and that will throw our custom error here, only buyer. That's how that works. So basically, if you were the buyer, only you can call certain functions, and same goes for only seller. That's implemented the same way. And what else do we have? Modifier in state. So here we're going to pass in a state, either created, locked, released, or inactive. And if the state of the contract is not in the state that you passed in, again, that function will revert. And we're going to call our invalid state modifier here. And we have some events we're kicking off for various functions: aborted, purchase confirmed, item received, seller refunded. So these are just log statements, basically. They don't actually affect the functionality of the contract. So let's look at our constructor. Constructor is payable, meaning when you deploy this contract and the seller is going to be the one deploying this, then you're going to send in some ETH along with it. And that's going to set the value of the value of the item. That's not set explicitly, it's actually set this way. So the amount that we've sent in as we deploy the contract, that gets kind of chopped in half, and then that becomes the value. The address of the person deploying the contract, that becomes the seller. And we do a check here that the value must be evenly divisible by 2. Otherwise, we revert to using this value not even error that we defined up here. And so that's contract setup. And we have 4 actual functions that are not the constructor that we can interact with, one of them being abort. Now, as we talked about, we can call this only in state.created. So we're here once we talked about the seller creates the contract, and they can abort if they do it before the buyer calls confirm purchase. Otherwise, once the buyer confirms and we move to the lock state, we can no longer call the abort function, and that is enforced by this in state modifier. And again, only the seller can call this. So that's how those modifiers come into play here. So once this gets called, we emit our aborted event, we change the state to inactive, and we go ahead and send the seller his money back that he put up when he deployed the contract. Now, confirm purchased. Let's see here. We can only call this when we're in the created state, which means again, the initial state. And this is what the buyer can call. And let's see. Oh, it's not confirming that. Estate condition payable. Oh, it does not say only buyer. Interesting. Okay. Well, anyway, so so we call it. The condition is that again that they have to send in twice the amount of the value, and we emit purchase confirmed. The buyer becomes message.sender and state becomes locked. I wonder if that's an error. I guess it wouldn't make sense for the seller to call this. So the seller's not incented to call this, but you should still enforce it. Anyway, so I think we should add a only buyer modifier here. But anyway, let's keep moving. So confirm received. Now, only buyer can call this, and we must be in the locked state, meaning this confirm purchase must have already been called. And now when the buyer buys this, we emit the item received event, we move the state to release. So we go from locked to release. And then the buyer gets half of his money back because the other half stays in the contract because that's the cost of the item. And then finally, we have refund seller. Again, only seller can call this. It must be in the release state. So the seller can't call this when it's in a locked or created state, only in released. So now we emit the seller refunded event. We change the state to inactive. And now we finally send the seller his money back. He's going to get 3 times the initial value or the value of the item because he posted up twice the value. That's just his collateral, basically. He gets that back. And plus the amount, half of the amount that the buyer put in. And that is it. We have officially gone over this contract and how it goes from created to locked to released to inactive. We have our state machine kind of, I don't know, picture here that we drew just for illustration purposes. We played with the contract and we saw how it all works, and that is it. I hope this was helpful. My name is Eric and I will work for CryptoPumps.